Okay, so this reads C is greater than 0, but we know that while they're trying to say by writing that C is greater than 0 is that C is positive. We know from all of the other transformations that when C is positive, we're going to shift the graph to the right. Shifting this particular graph to the right is going to change your domain, your end behavior, and your asymptotes. And the only thing that you have to be careful of is that if you know that you have a positive C value, that means you're going to see a negative C value. It's gonna look like it's a negative because the formula has the minus sign. We plugged in a positive number, so what we're looking at is an x minus 2, understanding that that 2 is positive. And since the 2 is positive, we're going to shift right 2, shift right 1, shift right 5. Okay, the next thing we're going to do is jump over here and look at the D values. D values, when D goes positive, it shifts up. When D is negative, it shifts down. Be careful. Seeing the shifting happen, it looks kind of like it's maybe changing shape. It is not changing shape. It is staying the exact same shape. We're simply changing its location. We're physically shoving it up or pushing it down. Okay, it is not changing its shape. So D does the same thing it always did, is it moves it up and down, only this time it doesn't affect anything other than it does change the x-intercept. Moving it up and down does change the x-intercept. But that's not really a big focus for log functions. It doesn't change the asymptote, it does not change the domain, so all we need to do is be able to describe that it shifts it up and down. So go back over here and add that information to your notes. All right, this one reads D is less than 0, but what that means is that D is negative. If D is negative, it's going to shift down. I will remind you, the same thing happened with exponentials. Sometimes they put the D value in front of the log. It doesn't not have to be written at the end. It can be written at the beginning like it is right here. What's the main difference between C and D? C must have parentheses around it. I really can't think of any time a publisher, I've seen any published document where they gave you a C and they didn't put it in the parentheses, because without the parentheses it would be almost impossible to distinguish between a C value and a D value. So C values are always going to be inside the parentheses. D values should not be inside any parentheses. And the same thing is true when D is positive, except you're going to shift up. And again, the number can be written in front of the log like it is right here, or it can be written behind the log. Okay, we're going to move on now to values of A. A is not any different. We know it's going to reflect when it's negative, it's going to stretch when it's a number bigger than 1, and it's going to shrink when it's a number that's between 0 and 1. So let's go over here and look. Here's the A value is 1. If I jump over here and make it negative, you can see that it's reflected. So this was an increasing function. Now it's a decreasing function. So that's one thing that reflecting the A does. It changes the type of function it is from increasing to decreasing. And when it is between 0 and 1, you see how if we start off at 1 and then we move it closer to 0, it's causing it to get shorter, or it's getting closer to the x-axis. Same thing when it starts off at -1 and we move it closer to the x-axis, or we move it closer to 0, it's getting closer to the x-axis. That's why we call it a shrink or a compression. Okay, but then when we move A on out, now it's getting further away from the x-axis. It is vertically stretching. It's getting taller. Same thing is true when we jump on out here and get bigger than -1. It's moving away from the x-axis. It's getting taller. So stretches and shrinks happen when you look at just the size of the number. The positive and negative tells you whether it's an increasing or a decreasing function, and the transformation the description of the transformation would be a vertical reflection. So let's jump back over here and fill all of this in, and we should be done with our transformations. I do have one more thing to talk to you about before we're completely finished. Okay, so I filled everything in. On these examples, I included both positive and negative because remember this absolute value sign says ignore the sign. I don't care whether it's a positive or a negative, but 2 is a number that's bigger than 1 and 3 is a number that's bigger than 1. And those are vertical stretches by a factor of 2, by a factor of 3. It would be, all of my y values would be 2 times as big. Vertical compressions, shrink. Again, I put both a positive and a negative because this absolute value sign says it shouldn't matter whether it's a positive or negative. If it's a number that's between 0 and 1, 1/2 and 0.5, or numbers between 0 and 1, then it's going to get shorter. It's going to get closer to the x-axis. It's going to be a vertical compression or a shrink. And then, of course, if it is negative, and it doesn't matter whether it has a negative with a number or just a -1, those are reflections over the x-axis, and it's going to change your graph from increasing to decreasing. All right, so I do want to go back over here and show you there are some parameter changes that we're not learning, but I do want to show you that I can let me do it to the parent function. I can put a number in front of that x, and when I do that, it looks like it's causing a stretch, and it kind of is, but because it's happening inside the function, that is what we call a horizontal, and that would actually be a horizontal compression. It pushed it closer to the y-axis. It also could be, whoops, I didn't mean to do that. It could also be a negative, and that negative would cause it to reflect over the y-axis. Those are changes that you'll probably learn whenever you are maybe doing pre-cal. If I was going to put a slider up there to represent those, I would have to put another set of parentheses right here, and since we already have a B in this one, I don't know, I might call it N. And then I would add a slider. And then that slider for N would show you the horizontal shrinks and compressions and the reflections. Okay, so there is another parameter that we could study. We don't study it in Algebra 2, but we certainly know that it does exist, and that's the one that determines what my x-intercept is. That's why I said we probably won't be calculating it. But if we had that parameter change right there, we would be able to see the change in the x-intercept. You will learn it later on when you are studying pre-cal or maybe college algebra. I'm not sure where, but anyway, you will see that in the future.